All right, let's talk about univariate analysis. What does this mean? This means we're going to start looking at the distributions um, of each and every one of some of our categories. We really want to dig deeper and kind of look for some issues or other things that we want to know about. Let's start with distance. So this, I'm going to start with a histogram, and I'm going to use a density plot. Remember, that's going to use percentage of the data, not the total count. So instead of being a count, it's going to be a density. And I'm also going to have a box plot of it as well. And so you can see right here, here's my box plot. And it'd be great if these were lined up perfectly. You could actually see that where the mean is, it fits perfectly. And you can kind of see the distance from town is predominantly right here in that 0 to 20 kilometers. And then there's just a few outliers. I mean, the furthest outlier is out here almost at 50 kilometers. Same thing we see here, distribution of them. The one downside of this thing is over here in these circles, it's hard to see. I mean, if they're different values because they're not perfect distances, we can kind of see them a little bit. But if these were integer values, they would really clump up a lot more. And we'll see that a little bit later on. But in both these distributions, we can see how skewed to the right it is, those long tails. Also, there's a whole bunch of outliers. All these little dots out here, outliers. Um, and so pretty much we can see that anything over 25 kilometers based on this box chart, this box plot, it really kind of shows that 25 kilometers is really the max, and then we drop stuff. And it makes sense there's nothing under 0 kilometers. If there's something was negative kilometers, I would be like, that's a problem. So that's part of the reason we do some of this stuff. If it has negatives and I'm not expecting negatives, we flag it. All right. Let's do the same thing on land size. And again, I'm going to do this as a KDE. So it's my density. And so it's just showing showing the line instead of all the different values. But the problem is I look at this, like it's just smashed. Like land size is crazy small. In both situations, it's hard to tell where that is. It's just super, super small, but it's obviously around, I don't know, 1,000. I don't know. But so right now it's in square meters. Remember, these are all in square meters because we can go back to the very top. I can take this and I can divide it by this, which is a quick reminder, is a million. Now you're like, wait, why did I divide by a million? Well, to go from meters to kilometers is 1,000, but at square kilometers. So that's a 1,000 times 1,000, which is a million. So I'm going to do this. Essentially, all this is going to do is it's just going to change my scaling. So my density stays the same, but this land size now change to be from instead of being 10,000, it's 0.01 and so forth. So it didn't really change. You actually the graphs look identical. The only downside is these x-axis. And that might be useful if you want to change it into a different term, if we're going to drop some stuff, other things like that. Again, skewed to the right, a whole bunch of outliers. We're going to have to look at this more. But let's just look like the biggest, you can clearly see that with this one. And again, even up here, that at 60,000, we got some outliers out here really far. Like that's a ginormous gap from like what, 42,000 to this. So let's look at those specific rows. This is going to remember, loc says, and then you put in whatever you want. It's going to identify when is this true and return the entire rows. And there's two rows. That makes sense what we saw. They're in two different suburbs. They're both have 3 rooms and are houses. Okay. So big houses on land size, that makes sense. Monstrous land size. The building area is missing. The year built is missing. One thing though I do notice is the distance. Like this one is 34 kilometers. That makes sense to have a really big plot of land that's pretty far out there. It means just own a really big chunk of land. Makes sense, right? However, this one does not make sense. That's only 10 kilometers from town. So the question is this an accurate land size or did someone hit an extra zero? Um, in situations like that, you kind of have to do a little bit of investigation. You might need to go back and check the records, especially if you're the one who's the author of it and knows where they came from. You can start asking a whole bunch of these questions, and really kind of dig into it and understand what's going on a little bit more. But again, postal code I don't really care about. Both have 3 bedrooms, 2-car garages. Okay. But their sale prices are also vastly different. This one is 2 million, whereas this one is just over 1 million. So this one's double the price, even though it's actually a little bit less land size. So that really does ask the question of what's going on here. I need to look at this a lot more. And for all we know, land sizes, it was a giant lot that someone bought. So we'll dig into it. That's again something, these are things that give you flags, and you can go back and double check your data before you do any kind of analysis, because outliers like this really mess with, if you're trying to do some kind of fitting and so forth, outliers really will mess with your fitting. I'll tell you that right now. But you don't want to just throw them away, because they actually are sometimes useful in true data. All right, so let's look at building area. Now, if we look at building area, again, it has a spike. We can see that right here in the 0 to 500 is where the spike really sits, and that fits the box. But we have these massive outliers. Now, notice that almost all of them stop. Even the first set of outliers stop at about 1,500 square meters. But this right here, these two are actually not that abnormal. This is actually extremely abnormal. From what I understand about sizes, like even large mansions are typically in this 3,000 to 4,000 range, not this 6 to 7. Like these are huge. So we need to kind of look at this a little bit more. We want to know more about it. So again, I just had it. So this was building area, and I did a disk plot. And if we do it again, we can kind of look at that. And again, we see the same outliers. Now we can see that values above 4,000 seem really, really high. So these are probably the biggest ones. We might want to look at them even more, and just dig into them and get a better sense about what on earth is going on here, so we can use that just to be more successful again. All right, so let's talk about price. Price is always one to look at. Notice, again, I put in its price, and it did price. Now, this is the key thing. 1E7. What does that mean? Well, that's a 1 followed by 7 zeros. So that's 10 million. Remember, this is calculator. So this right here is at 10 million. And it looks, based on the dots, there's one little dot way out here on the side that is clearly a little bit big, really, really big. But most of them are here in the, this is 0.2, so that'd be up to 2 million. Most are in the 0 to 2 million range, which again, I don't know Australian dollars. I don't know how normal that is. That's I don't know. Things seems, and again, you can see this massive outlier way out here. And this is why I love box plots. You see the outliers way better. Like this grouping right here, while their outliers are still clumped pretty solid, and then it starts breaking apart, and then it's like way out here. You know, these big gaps are like, that's something that's just really weird. All right, so again, we're going to come back to that. We're going to look at it a little bit more. We see its skewness and so forth. Let's look at rooms. Now, rooms, this gets fancy. Now, notice some of these are dark. That just probably tells me there's multiple things of those values. So here at 8 rooms, there's probably many, but I don't know how many. And that is actually part of the problem with a box plot, is it doesn't really show me that. But if I do this, it tells me there are 23 properties. Remember, this is how many rows have at least 7 rooms. So in all these outliers, since it looks like 7 is of that top whisker, anything over 7, because they're integers, would be true. So we have this, and we have 23. So now my question is, can you do the counts by unit type. So that means houses and so forth. So of the ones that have more than 7 rooms, 21 of them are houses and 2 are apartments or duplexes. Now, that kind of makes sense. I mean, a townhome, that doesn't make sense with 7, 8 rooms. 2, I mean, the apartments, you could have like a penthouse that has a whole bunch of rooms and some really craziness. You could also have a duplex that technically falls in that category, depending on the size of the duplex. So that usually makes sense. It's not really too crazy. Let's keep looking. Let's do a count plot because now I'm due by region. So this is categorical. So I want to just count up how many are in each of the regions. We already knew that the Victorians are small. And notice I rotated the labels 90 degrees so we can actually read the names. Otherwise, if I hadn't done that, it's a giant mess. So we want to leave that in there. All right, so we can obviously see which have the best, which have the smallest clumpings. I would even say if I'm looking at this, that northern and southern metropolitan, um, not only are they the biggest, but there's a significant drop. Those two are pretty close. And then this western is still a pretty big drop, and then an even bigger drop down to eastern, and then a really big drop down to Victorian. Like that's a huge drop off. So that it really makes the Victorian stand out. All right, so that is univariate is really I'm just going through and looking at distributions. Are they which direction are they skewed? What are outliers? What are things like this? Honestly, I don't spend a ton of time on this usually when I'm doing different analysis. I'm just trying to get a sense about what's going on.